This beautiful stretch of golden sand is known as Rotherhithe Beach, and over the other side of the river there is Wapping. And if you go way back to the 1800s, then the Port of London docks were a couple of miles upstream and London Bridge beyond them. But if you wanted to cross the river down here, it was a real problem. It's an awful long way to build a bridge, and if you did, you'd cut off the ships from the docks. So some engineers had the bright idea of going not over the river, but underneath in a tunnel.
The first attempt to build a tunnel under the Thames was made by a man called Ralph Dodd in 1798. He tried to build a tunnel between Gravesend and Tilbury, but he quickly ran into quicksand and out of money. In 1807, Richard Trevithick, the man responsible for inventing the steam locomotive, began work on a tunnel between Rotherhithe and Limehouse, but this caved in and was completely flooded. Work never resumed.
The chap who built the first successful tunnel under the Thames was Brunel. Not the flamboyant Isambard Kingdom Brunel, but his dad, Mark Brunel, who was a French engineer. Now the story goes that Mark, when he was working at Chatham Dockyard, was inspired by seeing a thing called a shipworm, Teredo nivalis, which used to bore its way into the oak timbers of ships, and eventually they crumbled. Now this walking stick has a handle made of driftwood, and I'm told that those wormholes are not actually woodworm, but shipworm, that is, Teredo nivalis.
The shipworm bores through wood using its powerful jaws and then lines the tunnel it's made with a hard excretion. This is what gave Mark Brunel the inspiration for the invention of the tunnelling shield. The miners would stand on platforms. In front of them were planks of wood holding back the soil. They'd unscrew one plank, remove 18 inches of soil from behind it, then push the plank into the hole. Then they'd unscrew the next plank and do the same. Eventually, when all the planks had been moved forward, the whole structure was pushed 18 inches towards Wapping. Then the area excavated behind the shield was lined with bricks, like the hard excretion of the shipworm.
So, with the help of his fabulous tunnelling shield, Brunel hoped to be able to tunnel right across to Wapping underneath this horrible mixture of sand and gravel.
There were to be two road tunnels running parallel to each other, one to take goods and trade vehicles from north to south, and the other from south to north. Mark Brunel might have found it easier to start a few hundred yards back and dig a gentle slope downwards, but that would have caused far too much disruption to the area.
So here on the Rotherhithe Bank in 1825, he built himself an engine house. That's the black chimney at the back there. And then he built an enormous brick cylinder. This thing that looks like concrete is actually bricks. The cylinder was 50 feet wide and 40 feet high. And when they'd finished it, they dug out the earth from inside and also from just around the outside, so that the whole thing sank slowly into the ground. And when it reached the bottom, and this is just the top sticking out, from the bottom of that shaft, he was able to start tunneling under the river.
Sadly, Mark Brunel was taken ill before the tunnelling even got underway in November of 1825, and it wasn't long before his 20-year-old son, Isambard Kingdom Brunel, stepped into his father's shoes as resident engineer, bringing with him a youthful enthusiasm. But enthusiasm alone couldn't help the fact that the seam of strong London clay they started digging through was far from continuous, and Isambard began to fear there was a real possibility that the Thames might burst through at any moment.
I want to know what London's actually built on, so I've come to the lab to meet Chris, who's a materials engineer. You know about these things, do you?
Certainly do, yes.
Yeah, good. So, is this what London's built on?
Basically, North London is built on this clay, which is ideal, it's cohesive, very hard to break.
It's very hard, isn't it?
Yeah.
I thought, it's a bit like plasticine, but extremely tough.
Yeah, it's an ideal tunnelling material, basically.
Is it?
Yeah, in North London.
Because it sticks together?
Yeah. So
okay.
Very cohesive.
And what happens in the south?
In the south we have the gravels.
Right.
South of the Thames we have the gravels, as you can see, not cohesive at all.
So you can't possibly make a gravel castle because it just collapses every time.
That's correct.
So if you tunnel through it, it'll just collapse into the tunnel all the time?
Basically just collapse on itself, yeah.
And then?
We also have the sand on the south of London.
Right. And what's this like?
As you can see,
Oh,
breaks very easy.
it just crumbles to bits. And what, can you make a sandcastle? Well, sort of.
You sort of can.
But it's very, very difficult, isn't it?
As you say, it's compared to the clay.
Yes. Ah, look, I made a sandcastle.
Yeah.
That was brilliant. And what's the worst problem with this?
The worst problem with that if it's moist, etc. Water,
Right,
etc.
right. So could we have some water on?
Would you like to pour the water on?
Okay, you're on. This is the
problem.
same sand, yes?
Yeah, the same sand. Yeah.
How much? A good slosh, you
Good
think?
slosh, as you can see.
Sort of a lot like that.
Yeah.
That's wet now. Okay, can I make a sandcastle? No, it simply collapses, doesn't it?
Exactly.
So is this what the problem was with the Brunel tunnel?
That's correct, yeah, the exact same problem.
So they started in clay, but they ran into gravel and sand,
Basically sand and gravel.
and it simply collapses.
To get a feel for what it must have been like for Brunel's miners, I decided to take a look at the tunnel myself. It's now part of the tube network between Wapping and Rotherhithe. Metronet, who now maintain the tunnel, were kind enough to show me round.
Working conditions down here must have been absolutely horrible. Imagine each miner standing in a little narrow wooden cupboard about this wide and just up to this height, and he's got these planks of wood in front of him. He's got to take one out, hack away the earth and the gravel from behind it, push it back in and down to the bottom. It's completely dark, okay? His only light is a candle probably stuck in his hat. The air is absolutely disgusting, thick, full of smoke, full of all sorts of horrible smells. The roof is perpetually leaking, and it's not leaking water, it's leaking raw sewage, because the whole of the Thames was just an open sewer. So it must have been completely foul. Men got really ill down here. And then they had a catastrophic flood in May of 1827, and they had to wall the thing up and pump all the water out and take all the mud out, and then to celebrate the fact they were going again, they had a great feast. Martin, tell me about the feast. It must have been around here, was it?
Yes, I believe it was in this area, and there were two separate tables. I believe the gentry were in this board here, and the workmen were in...
On the other tunnel.
It was a grand affair designed to rebuild confidence in the project. They even had the band of the Coldstream Guards on hand to play as the guests tucked into their lavish roast beef dinner.
In fact, that great celebration was a bit premature, because in January of 1828 there was another catastrophic flood. Many men died, and Isambard Brunel was pulled unconscious from the water with terrible internal injuries.
He was laid up for several months and began to suffer a series of hemorrhages. In fact, he took more than a year to recover. This second disaster gave the tunnel's investors the jitters. They were worried the project wouldn't be finished within the budget. In August 1828, the workers were paid off, and the tunnel, which had only reached halfway, was bricked up.
We must be just about halfway now, are we?
Yes.
Hey, and that's Wapping, yes, that light there. And if you look the other way, that's Rotherhithe. Fantastic. So we can see the whole width of the river. And it's, how far did you say?
365 metres.
365, about 400 yards from one side to the other. And we must be right underneath the river. It's not going to start leaking, is it?
No, I think we're safe enough.
Great.
7 years after the disaster, in March 1835, tunnelling resumed, after the Treasury coughed up a £270,000 loan. But 3 more floods drained funds, and when the excavation reached the North Bank in 1841, there was no money left to build the approach roads needed for goods vehicles. Only pedestrians would be able to use the tunnel.
So now there's a sort of doorway into the other tunnel. What do you call these?
These were one of 64 passages, cross passages that were installed in the original tunnel. Understand that in the early days, when it was in use as a pedestrian tunnel, lots of stall holders used to set up. And
Oh really? Selling whelks and things, and no trinkets. It's very elegant, isn't it? I mean, it's a nice. It's built to be looked at.
Indeed, and in the reconstructed section of the tunnel, we've replicated these features, so you'll see that they're pretty well identical.
Oh, fantastic! Let's go and have a look.
Martin Roach worked on the refurbishment of the tunnel in 1995. The team retained as much original brickwork as possible, and any repairs that had to be made also reflected Brunel's original design.
given that it's concrete, the shape is absolutely gorgeous, isn't it?
Yes, it was quite elaborate.
That's fabulous. I do like that. How many of these have you done?
56 in total.
You've done 56 new cross passages. That's terrific. Why don't you set up stalls in here?
Oh, we don't get too many people walking down here these days.
No, I guess you don't, no.
It's a shame that not many people get to see Brunel's handiwork close up. It can be easy to forget that what's now just a short stretch of tube was the first tunnel of its kind and was once even hailed as the 8th wonder of the world.
Now this is Brunel's original shaft. Look, this is the brick cylinder, his original bricks on the Wapping side. And this is one of the spiral staircases that he must have come up. I'm actually walking in the footsteps of the master, and indeed all his pedestrians must have come up the same way too.
I think it's great that such an important tunnel and shaft has been preserved so well, but in future, something tells me I'll be taking the lift.
Wow, I'm glad I don't have to do this too often. Whew. This is the Tower of London, arguably the most famous of all the London tourist attractions, visited by millions of tourists every year. But what none of them notice is this funny little building right next door. It says round the top, London Hydraulic Power Company Tower Subway, constructed AD 1868. And down under here, there is an example of what was arguably the most important step forward ever in tunnelling technology. Come down and have a look.
The tunnel, which runs right under the Thames, was constructed by James Greathead, a South African-born engineer and inventor. Originally, a lift was planned to take you the 60 feet down to the bottom of the shaft, but it didn't work very well, and a spiral staircase was put in to replace it. Unfortunately for me, not even the spiral staircase remains today.
So any advice?
Just hang on tight, mate.
Hang on tight, okay. That sounds like good advice to me. They say it's 60 feet down. It feels like about 160.
At the bottom of the shaft, I met Murray Briggs from Cable and Wireless, who now own the tunnel after buying it from the London Hydraulic Power Company.
Yes, welcome.
Wow, so these must be the high pressure water that the London Hydraulic Company was delivering, is that right?
Yes, I believe that's one of the old pipes, plus plenty of fibre optic cables that we've got through the tunnel over on the wall now.
Oh, these are fibre optics, are they?
Yes.
Ah, so now I understand why you're interested, because
That's why we needed the tunnel.
you don't do hydraulics, do you?
No.
Of course, the Tower Subway wasn't originally built for fibre optics or water pipes when it was first opened to the public in 1870.
Oh, how big is this?
It's 7 feet in diameter.
7 feet? Oh, hang on a sec. Look, I'm only 6 foot and I could bash my head on the roof.
Well, it's levelled off at the bottom.
Oh, I
That's
see.
where the tracks for the railway used to be.
They didn't run a railway through
They
here.
did.
I don't believe it.
It was a very small carriage that would just shuttle backwards and forwards on a rope, effectively.
Right, oh, on a piece of string. They didn't
Yes.
have a locomotive.
No.
I see.
It's
How
just-
many people would sit on it?
It's 14.
14.
14 people.
So here they've got tyres. Look, this really nice crisscross pattern here. Very elegant. Do you think they were there for the railway?
No, the railway only actually lasted for 3 months.
Really?
Yes.
But I guess it couldn't have made any money, could
No,
it?
it wasn't a success. 14 people at a time. There just weren't enough
Hopeless.
people going through
Hopeless.
to make any money.
So what did they do then?
They ripped that out and it was just a foot tunnel.
Oh, so that's why they wanted tiles.
Yes.
Right.
They just put a staircase at either end and charged people a halfpenny to come through.
Well, I bet they didn't get any customers, did they? I mean,
They did $1 million a year.
$1 million a
million a
year.
year.
That's 20,000 a week.
Yes.
Now, how did they make it? This is presumably cast iron, is it?
It is. This was revolutionary in its day. Brunel had built his tunnel down the river a few years beforehand. About
50 years, yeah.
Yes. That took 15 years to
Yeah.
build. But this tunnel, when it went through, was done in 10 months.
10 months?
And it cost £16,000.
That's
It
amazing.
was the Great Edge Shield was the technology they used.
So what's different about that?
Well, Brunel had used a shield to go through, which is
Yes.
effectively just a construction at the front of the tunnel to support the tunnel as you build it.
Yeah.
But here they used a round wrought iron shield with
Right.
a little door in that was effectively just pushed into the clay They opened the door, one man stepped through,
Right.
dug some clay out until there was room for another man to join him.
Right.
And then they dig as much clay out as they could.
Right.
Then the whole thing there were screw jacks. Excuse my head. Screw jacks that pushed against the cast iron.
And just
And
shove the
they
whole
just
thing
pushed
forward.
it forward, and then they put another section of the tunnelling.
Right, and just bolted it in. And it's all just bolted in.
Another thing James Greathead's new tunnelling shield had over Brunel's almost square shield was, of course, its shape.
This is a modern tunnel designed for commuter trains, actually for Thames Link. And it's virgin. You can see they haven't put the floor in, they haven't put the railway lines and various other bits of gubbins. And you can see because of that it's a perfect circle in cross-section, which is because that's an inherently strong shape. You see, if you have a flat roof on a tunnel, there are terrific forces from above, and eventually it's liable to give. But if you have a circle, that spreads the forces. Engineers call them hoop forces, and the forces go round the outside of the tunnel, and it's not going to buckle. It's a wonderful shape for a tunnel.
Unsuccessful as a rail tunnel, the Tower subway took another blow. Pedestrians stopped using it when Tower Bridge opened in 1894 and they could cross the Thames for free. But Greathead's work had not gone unnoticed, and he was about to use his tunnelling shield on a far more ambitious project.
Until the late 1880s, underground railways in London were built just below the surface, in cuttings, and then roofed over afterwards. This was called the cut and cover method, but it was very disruptive and also very expensive. So in 1886, Greathead was appointed to dig a deep tube railway, deep underground, from the city to the southern suburbs, specifically to Stockwell in South London. This eventually became part of the Northern Line. But going deep underground like that posed another problem for them, because steam trains couldn't operate deep down and they had to find a new method of propulsion.
The solution was the new technology of electric traction. Although electric tramways were becoming common in the United States of America, no one had ever tried to build an electric railway, let alone an underground one.
This is the Acton Depot of the London Transport Museum, and I'm with Christian Woolmer, who's written the definitive book about the London Underground. Now, Christian, what's interesting or special about this lump of machinery here?
Well, this is the first locomotive, electric locomotive, to be used on the London Underground. Basically, when they started building underground systems deep under the London clay, they couldn't use steam, and they had to have electric power.
And I guess once they got electric propulsion, they could dig a lot more lines.
Well, this was the whole change that enabled London to basically get a big network of underground lines, because initially there were steam lines near the surface, and now with electricity and with deep tunnel digging, they were able to build a whole network. And so we got 3 or 4 lines built, largely by an American called Charles Yerkes, who was a bit of a crook, because we're not quite sure how he raised his money, and his shareholders didn't do very well. But at least he gave us the Piccadilly line, part of the Northern Line, the Bakerloo line, all in the space of 4 or 5 years.
So you say Yerkes was a bit of a crook. How did he actually raise the money?
Well, actually, Yerkes was one of the first people to really use what later became known as junk bonds. Essentially, he issued paper on the basis of kind of promising to pay people lots of money, but which never really materialised, raised a lot of money like that, some staggering amount of money, £16 million, and paid for the system to be built. But we have to be very grateful to him, because without him, we might not have all these tube lines.
So, despite being great leaps forward in technology, all the tunnels we've looked at so far proved to be financial disasters. I went to see London's newest deep-level tunnel, the Channel Tunnel Rail Link at St Pancras, to find out how Brunel and Greathead's principles have evolved. I hoped that today's tunnellers were having fewer money worries than their predecessors.
In the old days, they dug tunnels by hand, but these were dug using a tunnel boring machine, or TBM. The TBMs are fantastic. They're 100 metres long. They weigh 1,100 tonnes. They're completely self-contained with a galley and loos and all that sort of stuff on board, and they work 24 hours a day. They have great big teeth in front to chew up the earth, and they spit it out the back onto a conveyor belt. And what they do is they go forward about 1.5 metres which takes about half an hour. Then they stop, and out the back they take these concrete segments to form the lining. They're picked up by a sucker. Boom, boom. 10 of them form a complete ring. They weigh 3 tons each. Absolutely extraordinary. And when they've made a complete ring, then the TBM moves forward again. I've come now right into the tunnel, right into the solid concrete here, and they tell me I'm 20 metres underground, which is a little bit scary, but actually there's a lot of tunnel and there's a lovely fresh air blowing through. And the chap who knows all about it is Gordon here. I think you live down here, is that right, Gordon?
More or less, yes. Yeah.
Now tell me, this is obviously the newest tunnel in London, I guess, is it?
Yes, indeed it is, yes.
And how much does it owe to all those pioneers, to the Brunels and to Greathead?
It owes very much, a lot to James Greathead in particular. These tunnels were driven with state-of-the-art tunnel boring machines that still adopt that same principle today.
This is all concrete, which is obviously they didn't use. Do you have any ironwork at all down here?
Yes, we do. We've still got some of the old techniques
Really?
in use, and we've used some of those techniques down here, so those hand techniques.
Ah, hey, this looks like some of those old tunnels. Looks together, bolted together by hand?
Bolted together by hand, yes.
And presumably this is steel, I mean modern stuff.
No, it's not steel, it's cast iron, more or less the same cast iron that's been in use for over 150 years.
Really?
Probably traced back to 1860.
How much influence do you think those early miners and their techniques have had on the shaping of the whole city?
Significant. Without those early traditional techniques being developed, we would not be London tunnels, or London tunnelling, or London would not be where it is today.
Those early pioneering tunnels that may not have made so much financial sense at the time have ultimately left a far greater legacy.
The technology that's developed since Brunel's original tunnelling shield over 150 years ago has allowed this vast and complex city to be woven together by hundreds of interconnecting underground tunnels lying below the streets of London. In fact, underground transport is now an integral part of every world city.